Hey, welcome to the Trackmania presentation. So our team is HRNS. I'm Henry, I'm the model trainer. Ryan was our UI developer. Nate was in charge of project management and testing, and Solomon was a general Python and CI/CD developer. So, what exactly was our original mission? It was to implement an impressive technical challenge using machine learning and AI principles. What does that mean? Well, there's an existing repository known as TMRL, which means Trackmania Reinforcement Learning, and we wanted to get into the nitty gritty of building upon that machine learning model. So we wanted to do things like um, overall, we wanted to improve the final performance that the model could achieve and also improve the speed at which it got to that. We wanted to lower the computational load and increase the rather decrease the time it took to get to that maximum performance. So we wanted to do things like add new features such as what gear the car is in and what speed it's at so that we could improve the model. Disappointingly, TMRL was a lot more of a black box than we were expecting, and we weren't able to add these features, and we weren't able to go in and write new CUDA code to improve the computational performance of the model. So we had to pivot. Luckily, we had a plan B. So this is a diagram of our old project design. If you'd like to view it, please pause and check it out. Same thing with the new project design. Feel free to pause here and look at that more closely. Now, what is our new goal? Our new goal was to develop a sandbox for users to train and test TMRL models with an improved user experience. Now, how can we go about that? Well, we created a library of models and tracks, as well as developed a GUI to allow users to interact with those. So it makes the whole process a lot more user-friendly, especially to novices in computer science. So we've pre-trained some models on tracks. Say we have a curvy model, so that was trained on a curvy track. We have a straight model, obviously trained on a straight track, and we want users to be able to say, hey, how does that curvy model perform on the straight track? How does the straight model perform on the curvy track? What if I do a little more training on the curvy model, but I do it on the straight track? How is it then going? Is it going to degrade the performance on the curvy track, improve the performance on the straight track? Those are the kind of questions that we want people to ask and want them to be able to answer in a fun, playful sandbox environment. I think that's enough of an intro. I'll go ahead and jump into the demo. So, first thing you got to do is obviously start up Trackmania. And start the GUI. Alright, now it'll take a moment. And I'm going to go ahead and select the curvy model. And the curvy track. Now when you go in, you need to immediately go into car view, and then we can just go ahead and test the curvy model. So this model was specifically trained on this track. It should be the most performant model on this track. When I'm done testing this one, I'll go ahead and pull up another model that we've trained and just see how that performs. You'll see the curvy model is actually doing pretty well. I would say this is similar to what a good human would perform, maybe a little bit better, but that's not the case when we use a different model. Say this model here. If we go ahead and run that, then it's going to be a little bit less performant. It was trained on a different track. It was in just our preliminary training, and you'll see it crashes into the wall. It's just not at the same level because it was trained on a different track. And that's true for our straight model, for the model that was trained on changing elevation. We've got all kinds of different models, and they'll perform all kinds of different ways on different tracks. And that's kind of like the interesting thing about the sandbox that we're creating. So So next, I'd like to go a little bit more into detail about the reward function, the LiDAR system, and how training is done. So we'll pull up a new command terminal and go ahead and record a reward function so we can see how that goes. Alright, so the user does need to initially complete a run on the track. The run can actually be very poor. It doesn't need to be this good quality run, and the model will eventually outperform it in most cases. It just needs this starting point to understand what the track is and what its goal ultimately is. Alright. And now we can go in and I want to show a little bit about the LiDAR system. Looks like we're having a bit of an issue. Alright, there we go. Don't know exactly what that was about, but this is the LiDAR system. So each of these vectors is pointed in a different direction, and the distance from the car to the wall is actually those are all the features that are being fed into our model. So each of those is terminating at the black pixels of the wall, and when those features are fed into the model, they're essentially run through a very complex series of matrices, and then the output is float values for throttle, for brake, and for left versus right turning. So that is then fed into a virtual gamepad, essentially an Xbox controller that is entirely virtual, that can communicate with Trackmania, and those gas, brake, and turn float values are turned into trigger values on the controller and a joystick direction on the controller. Next, I want to show how training is done. So if we were to choose to train this model, we would have to pull up 3 terminals. And then we'll start 3 separate commands. So the first one is the server. The second one is the trainer. And the final one is the worker. So we had the option to do these. These can be hosted in the cloud. We chose to run all of it locally, and we were able to do that because we had a powerful enough computer, and that was just much cheaper to do than pay for cloud resources. And as you can see, it's attempting to complete the track. This is our less performant model on the track. So, hopefully with many hours of training, it will get close to or, even exceed the performance of the Curvy model that we already have trained. That's pretty much all I wanted to demonstrate on Trackmania. And now I guess I'd like to jump into talking a little bit about the repositories. So there's obviously our own repo that we have, and then there is the TMRL repo. So I'll start with the TMRL repo because that's what you'll need to start with if you want to run our project. So TMRL stands for Trackmania Reinforcement Learning. You can go here and go through their Get Started to figure out how to download TMRL. And then once you have that installed, you can actually go over to our GitHub. And the 2 things you're going to need are the weights folder. So this has all of the weights, the models that we have trained. And you just take that and put it in your TMRL data folder, which for me is in users and then Henry. And as you can see, you can just replace the weights folder that you'll have with this new weights folder from our repo. Other than that, you just need to download the GUI code and run it. This example TMRL data path needs to be changed. So mine is different. That's just the location of that TMRL data folder. So that entire path, including TMRL data. And once you've done that, you'll be able to use our GUI and use our models and just enjoy the project that we developed. Before I sign off, I want to give a shout out to the other teammates, Ryan, Nate, and Solomon. I had a great time working with them, and it was just a great, fun project to get to work with machine learning all semester. So I'm happy with it, happy with those guys, and wishing everyone the best. Enjoy your summer.